So far, we have looked at how to use forward stepwise selection method to find the best model, which in terms of its fit on the validation data set. So let's say that we want to save these variable choices into the data tables if we can deploy it later. So the way you would do again is that we would click here on make model. This opens up the dialog box with just these variables selected, and we click on run. And then once this model is run, we can go to the red arrow and then save this model as a data table, to the data table. And let's call this forward selection. And then we can close this out. So here we have the forward selection chosen. But there are two other algorithms that we want to talk about on how do you make the model selection. So the second method that we will talk about is, again, we go to the stepwise dialog, but we'll look at backward selection. So click on fit model. Again, the same criteria. Our dependent variable is price. Everything else except validation is in our independent variables. And then our validation column is what we'll use for validation. And to do backward selection, we would again click stepwise. And then in the default option, instead of forward, we'll click on backward. So now in backward selection, the way model is built is that all these variables are included to start our estimation. And then the variable which is the least significant has the highest p-value is dropped first, and then subsequently other variables are dropped. So if we click on go, or we can just click on enter all, and then we click on go. So in backward selection, we're starting with all of these variables. And once the algorithm runs through, here again, we have metallic, automatic, and CC being dropped. So this is an example where the model that we came up with using backward selection was the same as we had come up with using the forward selection criteria. And again, we can click on make model, and we have this model that we have come up with, and we can click on run. And this is the estimation that we get with only the variables that were selected by the backward selection criteria being in the model. And again, as we said, that we have fuel type and diesel, which are with reference to the mean category. If we wanted them with reference to petrol, the omitted category, which is the more conventional way of doing it, we can click on response, click on estimates, and click indicator parameterization estimates. Now, the values on these are with reference to the petrol vehicle. So it says that CNG starts at $3,000 lower than petrol, and then diesel starts roughly $4,000 lower than petrol, giving everything else the same. There is another algorithm which is used quite extensively, and that is called the exhaustive search method. In exhaustive search, the algorithm chooses various models with a given number of explanatory variables and then finds the top 2 or top 3 models in those. So for example, it'll build a model with just one predictor variable, then build a model with just 2 predictor variables, and then out of these it'll just pick the ones that give the highest accuracy in terms of the stats based on the validation data set and so forth. So to run that model, we would click on this red arrow. The dialog is called all possible models. This is the exhaustive search algorithm. here we want to say that at the most we want, let's say, 10 terms in the model. So it won't build a model with more than 10 explanatory variables. And let's restrict how many models get demonstrated. So we'll just say maybe we want to see top 3 models with each set of combination of explanatory variables. We click OK. So now it has built models with first just one variable. Among these, including age, does the best job as far as the kind of information criteria is concerned. And we can add more diagnostics also. Just click on column. We can see the malus C as well. And really high malus C means the model is underfitting. So even though, yes, we have uh, lower AIC and lower RMSE among just one variables, but this is a highly underfit model. When two variables are chosen, it came up with age and weight as better, and it looked through age and horsepower and age and mileage and so forth. So then in this case, when 7 variables are chosen, this is the best combination that JMP came up with. And in this combination, we have the root mean square error as 1249 and so forth. So among all of these, it seems that the 10, 9, and 8 variable models seem to be doing well. So if you were to make a pick, again, we don't want to have too many explanatory variables because then it may be hard to fit the model to new data, but we don't want to underfit our model as well. And one quick check is to see that the malus C is fairly close to the number of predictors plus the intercept. So in this case, we might be inclined to go with either the 8 or the 9 selection models. If we were to go with the 8 selection model, then the variables to be included would be age, mileage, fuel type, horsepower, doors, quarterly tax, and weight. And if you recall, this is kind of the same model that backward selection had chosen for us. CP is not too far off the number of predictors, and the root mean square error is 1241. It is slightly lower in the 9 predictor model. The AIC criteria or the BIC criteria both are, BIC is lower and AIC is a little higher. So it is a wash between these two, and we could potentially choose either of these two models and then see which one does well with our new data. So if I click on the 8 and the radio button, then this is the one that will be chosen. Up is same as what we had done with both stepwise forward and backward. So if we again click on make model, then we have just these variables included, and then we can run this model as well and then save this as exhaustive search. So with response, and then as I said, we can click on estimates, indicative parameterization estimates, to get the more conventional interpretation of timing variables, and which is same as what we have been getting all along with the various criteria. And then to save this, we go to this little red arrow and then click on save script to data table, and then we can call it exhaustive. And then save this. So now in our data table, we have the forward selection, and then we can do the same for backward or exhaustive search being saved. Now, how would we use these models to score new data?